11.212. That one right over there on the left. No wait, 11.2. Is this this 12 right here? Matching? Is that the one you want to talk about? Yeah, you can do this piece by piece. What you do you remember the tip I gave you about how to approach these? Do you remember? Look at important and interesting things. Don't try to do all of them. You look at like one specific point or one specific line or one specific set of points, and then do it by a process of elimination. Do it by a process of elimination. That's how I would go about doing it. So let me see if I can clip these in properly. So for this one right here, let's just look at the first two and see if we can match the first two. Let's go to there. Okay, so this is full screen. I'll turn this over. Thanks, guys. So match the slope fields here. So for example, y prime is equal to negative y. Let's take a look at these here for a second. Okay, any negative, right? Above the y-axis, they're all going to be negative. And they're all going to be the same. On this one right here, they're all going to be the slopes are all going to be the same on horizontal lines above on horizontal. Is there an x involved in this right here? Is there an x? That x never comes into play. So let's look above the x-axis. Oh, some are positive, so not that one. These are all what? They're all negative. What about this one? Positive, positive, and some positive. Oh, so did we just find it? Yeah, so which one is it? It's 2. So we know that this one is going to be A. Nice. Okay, what about this one, B? They're all positive, right? They're all positive as y gets bigger. As y gets bigger. So which one's that going to be? I'll say all positive. These are all positive as well. These are also all positive. So it's not that one, right? Because some of those are negative. So how do we go about figuring out which one it is for B? They all have to be the same across. Exactly. They all have to be the same going across. So let's zoom in on this one. Does it look like they're all the same going across? What about this one? Do they all look the same going across? They kind of do. What about this one right here? This one, do they look like they're all the same going across? They do look like they're all the same going across. Ah, and then you also notice as y gets larger, the slopes have to get larger, right? Is that happening here? Yes. What about here? No. And what about here? As y gets higher, does it increase? It does. Okay. So now we're down to these two right here. Now what are the differences between, what's the difference here? The area below the x-axis. So one of them goes, the one up top kind of goes like this, and the other one goes like that, right? So what do we know what's going to happen below the x-axis here? All the slopes have to be what? Negative, right? All the slopes have to be negative. What about right here? Are these negative? No. So which one does it have to be? It has to be this one. So this one is B. You can do all of these like this. You can do all of these like this. Look for interesting things. Look for interesting things. Look for interesting things. Cool. Slope times what? Delta x. So we need to do slope times delta x. Well, we have this point negative 1, 0, and we know that this is y prime. So what's the slope going to be? And what's delta x? 0.1. So we know delta y is therefore going to be negative 0.1. What do you do? What do you do with that negative? Ow! Oh, ow! Nice gap. That's nice. We add delta x, which is 0.1, right? So it's negative what? 0.9. So now we just do the same thing. We do the exact same thing over again, right? So now what's the slope? You add them together. What is it? Negative what? Y prime is the sum of the two numbers. So what's the sum of those two numbers? Negative 1 again. Oh, that's pretty cool. What's the step? What does it equal? Negative 0.1, right? So how do we get the next x value? We add it and get to negative 0.8. So what is the next y value going to be? Negative 0.2. Ah, Umi, great pick, because you're actually on a really interesting part of the slope field. You actually picked a part of the slope field where if you plotted the solution, what do you get? You get a line. it's really cool. If you plot the solution, you get a line. So if you keep on doing this, it's asking you to estimate, what does it say? Estimate y when x is equal to 0.4. How far do we have to keep going? You have to keep going, right? You have to keep doing the same thing, right? So if you keep on doing this, this thing is always going to keep on going up by delta x, and the other one's going to keep on going up by negative 0.01, right? So if you keep on doing this, you end up with, you're going to, pause it here, stay. Sorry, kids. What does the slope stay? Yeah, it stays constant the entire time. And that's nice. I love ubiquity on this thing. So it stays -1. So how could we prove that? Let's just do that as a side note to this. We can deal with this because is this differential equation considered to be that complicated? Not really. So this tells us that dy dx is equal to x plus y. If we wanted to integrate this, what would we have to do first? What's the first word? Separate. You have to separate. So what do you end up with here? You could have dy is equal to x plus dx, correct? You have to be really careful when you do this. You have to be super careful. Can you just divide by y right now? No. So you end up with dy is equal to x dx plus y dx. What do we do now? I'm serious. Like, what we want to get, we don't want the dx there, correct? So maybe we're like, dy minus y dx is equal to x dx, right? Does that seem to help us at all? There are differential equations. That's the whole point of Euler's method, is that there are differential equations that are really hard to work with. Step one in finding a solution for a differential equation is separation of variables. Is this separation of variables at all easy? No. So we're like, okay, I'm frowny facey right. I'm frowny face right now. Maybe I'm going to take another tact right here. Another tact would be dy over x plus y is equal to what? Dx. You can do that, right? I can cross multiply. Is that legal? What I did there? I think it is. So what do we end up with? Dy. Ugh, it's just awful. So don't. But the reason I show that to you is just because it looks like it's easy doesn't mean it's necessarily going to be easy to integrate. Does that kind of make sense? But if you saw the slope field of this, what would you see at -1, 0? You'd see a point, and it would be on a line. All of the slope field little segments would be in a line with a slope of what? -1. -1. Solution path is going to look like on that slope field. It's going to be a straight line going in both directions, right? Similarly, on the other one, you'd see it at -1, 0. It would have a slope of -1. Okay, that's fine. That's fine. Okay, ready? So yeah, so go the other direction. We know that y prime is equal to y, so that means dy dx is equal to what? Y. I'm just writing it as dy dx instead. So that means dy over y is equal to dx. Now what can you do to both sides? So you end up with ln of absolute value of y is equal to x plus some constant. So let's say constant 1. So e to the x plus c1 is equal to the absolute value of y, but e to any power is going to be positive. So therefore you have e to the c1, e to the x is equal to y. And what did we do yesterday? What did we call this right here? We'll call it c2. So we know y is equal to c2 e to the x. Does it give you an initial condition? y0 is 1. y0 is 1. It tells you y0 is 1, so that means when x is 0, y is 1. So we have 1 is equal to c2 e to the 0. So what does that mean c2 has to be? 1. So what's our final solution? Y equals e to the x. Okay, so this is the question I would like you to work on right now. Help you study. So please work on this one right here. Right here. So r equals 2 for the circle. How do you go about finding the line? What is that? What does x equal? X is equal to r cosine theta. So if x is equal to 1, what do you plug in for x? 1. 1 is r cosine theta. So if we want to isolate r, what does that mean r is? Yeah, there you go. So now you should be equipped enough to do